Unsupervised learning sounds mysterious, right? But at its core, it's just a clever way for machines to find patterns in data, with zero help from humans. No labels, no hints, just raw information. Let's start with clustering. Imagine you've got a box full of socks in all sorts of colors and patterns. You don't tell the machine which socks are which, but you want it to group them into piles, maybe by color, size, or pattern. That's clustering. And one of the coolest ways to do it is called k-means. Now, with k-means, you pick a number, let's call it k, for how many clusters you want. The algorithm randomly drops k-pins or centroids in your data. Then it looks at each sock, figures out which pin it's closest to, and sorts it into a pile. After seeing all the socks, it moves each pin to the center of its pile and repeats this process. Eventually, the piles and their centers settle down, and boom, you've got your clusters. The tricky part? Picking the right value for k. Too many piles and things get messy. Too few, and you miss important differences. But what if you don't know how many clusters you need? That's where hierarchical clustering steps in. Instead of picking a number, this method builds a tree. Imagine a branching family tree for your socks. Starting with each sock as its own little cluster, it merges the closest ones, step by step, until everything's grouped together. Or it can start with one big pile and break it down. The result is a dendrogram, a tree diagram that shows how your socks, or data, group together at every level. All right, let's switch gears to dimensionality reduction. Suppose you've got a spreadsheet with 100 columns describing each sock. Color, size, fuzziness, material, you name it. That's a lot of information. Dimensionality reduction helps you cut down those columns, making your data simpler and easier to explore. The most popular tool here is Principal Component Analysis, or PCA. Think of it as finding new axes, directions that explain the most about your data. The first principal component captures the biggest differences, the next one grabs what's left, and so on. Keep the top few and you keep most of the important info while tossing the rest. Then there's TSNE, a mouthful, I know. T-Distributed Stochastic Neighbor Embedding. This one's all about visualization. It takes complex, high-dimensional data and arranges it on a 2D or 3D map, placing similar items close together and pushing dissimilar ones apart. Perfect for seeing patterns at a glance, but not so great for actually building models. So, unsupervised learning? It's all about uncovering hidden structure. Whether you're grouping socks, simplifying data, or just visualizing the chaos, machines are quietly finding order in the mess, and that's the magic.